Number 10, we have photochromic glass, and which the amount of light being passed through the glass is controlled by the amount of silver atoms. So which is shown in reaction 1, where silver plus becomes silver atoms. So in this direction, the glass darkens. Silver atoms can also be converted back to silver plus, and in this case, the glass allows more light to pass through. Right, but the exchange of electrons is not between silver and chloride directly. They are facilitated by copper 2 plus and copper plus. So you can see reaction 2, copper plus pass an electron to chlorides, and then forming copper 2 plus, and then copper 2 plus will accept an electron from silver to form back copper plus. So that's the copper ions facilitate the exchange of electrons. They act as catalysts. We can also eliminate the other options. Option B, copper ions, copper plus ions acts as an oxidizing agent. In reaction 2, copper plus is itself oxidized. So copper plus is actually a reducing agent. You can see that chlorine is reduced. So copper plus is a reducing agent. Reaction 3 increases the darkness of the glass. If you look at reaction 3, it decreases the amount of silver atoms. Right. So actually it decreases the darkness of the glass. Because the more silver atoms you have, the darker the glass will be. And then option D, silver atoms are reduced. Silver atoms, Ag becomes Ag plus, silver atoms are oxidized. So we confirm that B, C and D are not correct options. (11) We have a Boltzmann distribution curve at a given temperature. What happens when the temperature is increased? You have to know the shape of the curve when the temperature is increased. The peak will be on the right, okay, but it will be lower than before. So the value of the peak shifts to the right, and fewer molecules possess the most probable energy. So this is the most probable energy at a lower temperature. This is the most, or rather this is the most probable energy, and this is the number of molecules at that amount of energy. When we have higher temperature, this is the most probable energy, and we have lesser molecules at the most probable energy than before. A simple way of putting it is the peak actually is lower. So B is the option. Number 12, we decompose nitrates, group 2, and we have this amount of gas. So you have to know that nitrates decomposition, we get oxides, nitrogen dioxides and oxygen. This is a very often repeated questions in the past exam papers. Right? So once we have this equation, this is the amount of gas produced, which is actually the nitrogen dioxides and oxygen. We take the difference because by conservation of mass, we will know that the difference is the amount of the oxides or your metal oxide. This is a solid. Right? These are gases. So the difference allows us to find the mass of the solid remaining. Then back to the equation, 1 mole of your nitrates will produce 1 mole of your metal oxides. So if we have 3 grams, we convert this to moles based on the molar mass. where X is the unknown molar mass of the element X. So 3 over X plus 124. This we convert to is number of moles also, X plus 16. Right, again I say they are the same because 1 mole will be 1 mole for the nitrates and the oxides. Once you have this equation, it's just a simple mathematical manipulation to find out the unknown X. We can cross multiply. We bring our denominators to the top. Open up the brackets. And then we solve for your X. X is your unknown molecular mass, relative molecular mass, or relative atomic mass to be exact. You compare this to the periodic table, you can see that strontium will be the one that has the closest atomic mass. So it is strontium nitrate. Number 13. What happens if we place magnesium ribbon in cold water? Cold water, the magnesium will react, but not vigorously. You will form magnesium hydroxides, and then hydrogen gas will be released. That will be the bubbles that we observe. Right. Option D, if you are thinking why does it look familiar, this is the description where magnesium is burned in air. You get a glowing magnesium, and then you get magnesium oxide. (14) Compound X releases carbon dioxide when heated. So it is a decomposition of your carbonates that will eliminate B and D, which are not carbonates. Right, these are decomposition of carbonates. And then between calcium carbonate and magnesium carbonates, we have to know that we have to look at the second use. Compound Y is used as a refractory lining. This you require the background knowledge that magnesium oxide is a lining because of its high melting point. So we want magnesium carbonate instead of calcium carbonate. (15) Which one correctly describes the electronegativity? We can use the trends of the electronegativity first. As you go from left to right in the periodic table, the electronegativity will increase. So just on the electronegativity, from sodium to silicon in order. Right, sodium lowest, magnesium second, aluminium third, silicon is the highest. So A and B are possible choices. Right, C and D, based just on electronegativity trends alone, eliminated. And then we compare their ionization energy. The difference between A and B options are aluminium and magnesium. Here it says aluminium is higher ionization energy. Here it says magnesium is higher. The ionization energy, although generally increases across a period, there are certain exceptions that we have to be careful of. Magnesium, we are removing the electron from an s2 orbital, whereas for aluminium, it's already filled s2, we are removing from p1, a p orbital. So it's easier to remove from a p orbital than an s orbital. So actually the first ionization energy for aluminium is lower. Right. If you are not convinced about this, you can also check the data booklet where they will list numerically the ionization energy, and then you can have an easy comparison between aluminium and magnesium. So either you reason it out or you check the data booklet to compare the values for first IE of aluminium and magnesium. Number 16, electrolysis of brine, concentrated sodium chloride. So be very confident or familiar with this case study, electrolysis of brine. On the anode side, we have oxidation. Your chlorides will become chlorine gas. You'll be oxidized, so chlorine gas release. On this side, we have water being oxidized or being reduced. We form hydrogen gas, which is released, and then your hydroxide ions are accumulated on this end. So what don't we want them to react? We have hydroxides here. To be more specific, we have sodium hydroxide because we have sodium ions. Sodium hydroxide will react with chlorine. Sodium hydroxide and chlorine gas. We get our sodium chloride and sodium hypochlorite. So mixing S and P will give us sodium chlorate, which is why we actually have a diaphragm here, so that we don't get them mixed and then we lose our intended products. (17) Which one of ammonium ion is correct? All bond angles are 107. Ammonium ions, I put it here. These are all your covalent bonds, and if you want to be even more specific, this is a dative bond. Because ammonia NH3 has one lone pair, and then your hydrogen ion has no electrons. So there will be a covalent bond, which is actually a dative bond. So there are no lone pairs on the nitrogen in the ammonium ion. So 4 bond pairs, 0 lone pairs, it is tetrahedral. It's about 109.5 degrees. So option A is out. Ammonium ions are formed when ammonia behaves as an acid. Right. Ammonia accepts a proton. A proton acceptor is a base. Right? Because it accepts a proton to form ammonium, it is actually behaving like a base. Ammonium ions are unreactive when heated with sodium hydroxide. This one you have to recall the reactions. Ammonium, sodium hydroxide, we get salt, we get water, and most importantly we get ammonia gas. This is actually the test for ammonium ions. So there will be a reaction. All the bonds are the same length because basically they are nitrogen-hydrogen bonds. So the orbitals have the same length, or the distance between the two atoms are the same. So D is the answer.